We're going to be using this Explore Learning to connect a lot of different concepts. So you'll see that there's several different tabs at the top. We'll move through these together because they're a little bit more complicated than a lot of the Explore Learnings that we look at. The first screen just shows you a picture of a piece of space divided into 9 regions, A through I. You can click on any of these regions and you'll see what is in there. And you can click Return to the Map to return to the map and pick a different region at any time. The Gizmo warm-up has us starting in region A, and we're going to be looking for those Cepheid stars that Henrietta found and looked for those rotations in. You can identify them really easily because you'll see that they get brighter and dimmer. So here's one that gets brighter and dimmer, and here's one that gets brighter and dimmer, and that's its apparent brightness, okay? And Henrietta Swan Leavitt noticed that relationship, and that's how we're going to be able to tell at first how far away these stars are. When you click on one of the stars, it's going to highlight it in this red circle and give you the option to collect data. And you'll see it starts graphing the apparent brightness of that star immediately for you. So it goes up as it gets brighter and down as it gets dimmer. Okay? And there's a couple options here. You can show the time probes, and you get 2 of those time probes that you can drag and drop. And they're just going to let you see different times in it. So if I put it right here on 6, I can tell that time probe's at 6 days. If I put this one at 2, I can tell it's at 2 days. And I'm going to use those to find how long it takes this pattern of going bright and dim to repeat itself. Because remember, that's what Henrietta Leavitt used to tell us how bright the stars were. So I'm going to put one time probe at the very beginning when it is at that equilibrium point, and I'm going to put the next time probe at the next time it counts equilibrium. I just think that makes it easy because this one's at 0, and I can see this one's at 4.1 days. So there's a chart over on the left that I can use, and this is actually the chart that you have on your data sheet, and you can move left and right through this chart. And the first thing it asks me to record is the period or days, and that's how long it takes for this cycle to repeat. And it's 4.1 days, and I'll just enter that data here. I like using this table because it's going to do part of the math for me. Now, it also asks for the average brightness. So the average brightness would be if I took the brightest and the dimmest and averaged them, and that's going to be right on this line. And I can click it, and it tells me the average brightness of this is 2499. That's how bright it is on average. The next thing I need is the mean luminosity, and I'm going to find that using Henrietta Leavitt's math. If I click on distance, it's going to show me a graph. And this graph is the same line that Henrietta found when she first observed those Cepheid stars when she was analyzing her data. So if you'll click on this Show Draggable Point, you have a point that you can move, and at the bottom is the period, and here is the mean luminosity, but if you drag that point, it'll show you. So we are looking for a period of 4.1 days, so I'll drag that to 4.1, and then it's going to tell me that it has a luminosity of 1,560 suns, which means it's 1,560 times brighter than our sun. And all these Cepheid stars are pretty big, so they're mostly going to be brighter. And then this little spreadsheet finds the luminosity to brightness ratio for you. But that is just the mean luminosity divided by the mean brightness. For this one, we get a ratio of 0.624. Now, there's another graph built into this page. When I click the distance versus luminosity ratio, remember I just found this luminosity ratio, I can now use that to see how far away that star is. And if you remember our little cell phone stars with Miss Buck and Miss Pearson, as a star moves away, it will decrease in luminosity in a specific way. So now that I know that ratio, I'm going to zoom in some because I'm looking for 0.624 luminosity and brightness. That is not a very big number. So I'll just try to get close to it. That's pretty close. So I put in that luminosity, and it gives me a distance, and that's 0.78 megaparsecs, which is pretty close because this star is in the Andromeda Galaxy, which is our closest neighbor. We'll stop there for now, and we'll come back to redshift in just a little bit.